Hi everyone, welcome to this new video lecture of AutoCAD. In this lecture, we will discuss about the projection of solid. So before going to the diagram in the AutoCAD, so let's discuss about some theory part of the projection of solid. The solid actually, it is known as the orthographic projection of three-dimensional, which is having length, breadth and thickness, is called solid. And a projection already we have discussed because we have already completed the projection of points, lines, planes, okay. And so in this lecture we'll discuss the part of projection of solid, like solid, what are the types of solid and how it looks like, and what are the structure of the solids are there. So solid actually it's categorized into two types. One is right solid and another is oblique solid. And again the right solid is divided into polyhedron and another one is solid of revolution. In the polyhedron again it is categorized into few types are there, like three types is there. One is regular polyhedron, another one is prism, another one is pyramid. Similarly in the solid of revolution it is categorized into three different types. One is cylinder, cone and sphere. Let's discuss all these points one by one. So first is regular polyhedron. So in the regular polyhedron again it is categorized into few different types are there, like tetrahedron, cube, octahedron, dodecahedron and icosahedron. These are the types of regular polyhedron. And under prism again it is different types of prisms are there, like triangular prism, square prism, pentagonal prism, hexagonal prism and many more are there similarly. Similar in the pyramid, again it is also similar types, like what are the types I told here, same similar types of pyramids are there, triangular pyramid, square, pentagonal, hexagonal, etc. Now in the regular polyhedron actually we are having different surfaces are there and all the surfaces will be similar kind, everyone same here. And prism, if you see, that the top and bottom surface will be same and other sides will be like rectangular type. And pyramid base will be the types, the objects, and all the side surfaces are triangle type. So let's discuss one by one. First one is polyhedron. The polyhedron actually the solid bounded by planes is called a face. So these are the face are there. You can see these are the faces of the each polyhedron. These are one face, this is one face, and that side one face, this side one face. Okay, so this is actually tetrahedron. This is the surface. If you can see, this is a tetrahedron surface is there, and all these lines are called these are the edges. These are the things what you are seeing. These are the edges. And these are the points, these are corner things, are the joint point of these lines is called a edge, corner point. You can say these are the corner points of this solid, and these are the lines are there. Okay, and these are the surfaces are there. So when planes will be meet each other, okay, and like these are the planes are there. If you combine all these planes, you will get a solid, which is having length is there and height is there and width is there. Okay, so the polyhedron actually it is of different types are there, like tetrahedron. Tetrahedron is having four equal equilateral triangle faces. Now see in the polyhedron tetrahedron actually these all sides are triangular surfaces are there, equilateral triangle actually. Here these two lines will be same, okay, and four surfaces are there. Similar in cube, if you see the cube, normal cube is there. So how many surfaces is there? 6. This is 1, 2, 3. This is 4, 5, and the top is 6 is there. So all the sides are there. That is 6 surfaces are there, and all sides are, you can see, square are there. This is one side square. This is one side square, and this is all the sides are square are there. Now next coming to the octahedron. Octahedron actually this is 8 equal equilateral triangle. So here it is 4 equilateral triangle. Now in the octahedron it is 8 equilateral triangle surfaces there, and all like triangles will be equal, like all surfaces will be same. Similarly dodecahedron it is of 12 surfaces are there, like this. If you see, it is of 12 surfaces on all faces are, all these faces are pentagon in shape. So this is one face, this is one face, this is one face, this is one face. So all these faces are pentagonal faces, and total how many? 12 faces are there. Similarly, icosahedron, it is of total 20 faces are there, and all faces are equilateral triangular faces here. Okay. So everywhere it's like you can say that all these sides are same in the triangle here. So this is about polyhedron. The prism. Next is the prism. So prism is a polyhedron with two end sides polygonal bases which are parallel and congruent, and the lateral faces are rectangles, and imaginary line that joins the center of the bases is called an axis. So here let me tell you, this is a triangular prism, this is a square prism, and this is pentagonal prism, this is hexagonal prism. Okay, so prism, as I told you, all the sides, all sides are similar. It's like a rectangular face. All these sides are rectangle. This is one side, this is one side, and the side one side is there. So three surfaces are there in the triangle, because the triangle three sides are there. So three sides, the joint will be like this. Is the triangle is there. Let me draw this triangle here, and this is a base triangle is there. So this is the base, and this is the top. This is the base part, and this is the top part is there. Okay. So top also triangle, base also triangle. Now if you join this triangle top and base by the line, and so that you will get all these three surfaces. So this is called edge. This is called edge. This is called edge. All these things are edges. And similarly, the square. So top will be square, and bottom will be square, and all the sides will be rectangular faces. Okay. So, and the center point, like say this is the meeting point of this. If I join this corner, and this diagonal point, joining point will be called a center point of this. Similarly, if I join this diagonal of this, then I'll get the center point. If I join this one, this is called your axis. This is called the axis of that point. Similarly, the pentagon purpose, this is top will be a pentagon, bottom will be pentagon, and these are the bases, end of the base, and this is the top bases. Okay, and this is the axis point. This is the axis line of this pentagon and the axis line of the hexagon. So only the difference will be here. What are the objects we are giving? So objects is nothing but like a triangle, square, pentagon, hexagon, and prism is the shape of the size, the shape of that objects, we can say, how it structures. So it is given like prism, like triangular prism is base will be triangle, top will be triangle, and all the surface will be, all the sides will be rectangle. Similarly, pyramid. So pyramid actually, if I take the pyramid here, the base will be your object. The base part, this is the base part is there. So base is your object. That means if I tell this is a triangular pyramid, then the base will be our triangle. If I tell a square pyramid is there, then the base will be square, and from this, each of this corner of the base or the corner of this triangle, you can say there will be a line, and this is your slant edges line. Actually, these are the lines. It is called as slant edge. Okay, all these lines are called as a slant edges, and the top of this part, top of this joint of this slant edges, that is called your apex part, and the middle of this is called your axis. Okay, so pyramid will be look like this. So the base will be the object, that which kind of pyramid it is, and all the sides will be triangular in faces, and this is top part is apex, and all these sides the faces are there, and this is of a square pyramid. So we are having total 4 sides are there in this, 1 2 3 4, and the base will be our square. Okay, similarly pentagon, so base will be your pentagon, and all these 5 surfaces will be, 5 faces will be there. Similarly hexagon, this will be 6, and all the 6 sides will be there. Each side, each of the sides are all a triangle. Okay, and these are the called as a corner of this. I already told you, these are the points, corner of the object, and these inside points, inside lines are given dotted line, because we are seeing, suppose in this front side So that back side of this object will be not visible to us. So that's why it is given in dotted line. So which points or which lines will be not visible from the any kind of view, so that can be mentioned by dotted lines. So this is about the pyramid. Now the solid of revolution actually. So solid of revolution is three different types are there. Three different. One is cylinder. This is our cylinder is there, and this is our cone. Another one is sphere. So this solids are obtained by revolving a plane like rectangle, triangle, and semicircle. Now the cylinder will be framed if I take a base, like this is the suppose one plane is there. This is a rectangular plane, okay, and this rectangular plane, if I revolve in the, this is suppose axis line is there, through this axis line if I revolve this one, then there will be a cylinder will be framed here. Okay, if I revolve this rectangle on this on the around of this axis, then I'll get the cylinder. Similarly, if I revolve the triangle around this axis, this is triangle is there, and suppose this is the axis line is there. If I revolve this triangle around this axis, then I'll get a cone. Similarly, this is the sphere is there. So if this is the semicircle is there, if I revolve the semicircle around its axis, then I'll get the sphere. Now next is frustum of pyramid and cone. Actually, this is the square pyramid, and this is the hexagonal pyramid, and this is the cone. Three objects are there. Now how the frustum will be framed? How the frustum will be framed from the pyramid and cone? So when a regular pyramid or cone is cut by a plane parallel to the base, that means one plane will be there. Suppose this is the plane is there, and the plane will be cut the object. Which object? The square pyramid, which is parallel to the base. So this is the base is there. The base, whatever it may be a pentagonal pyramid, square pyramid, or hexagonal pyramid, whatever the pyramids are there. So this plane will be parallel to the base, and it will be cut. Suppose if I extend this line, I'll get a conical in shape here. Now see, this is the pyramid shape, not conical. This is the pyramid in shape. Now this object, if I cut by a external plane, by which is parallel to the base, this plane is parallel to the base. So if I cut this one, then I'll get the frustum here. That means the top part of the frustum will be similar to the base one, like a square. Okay. So if it's a square, base is square, top also here I will get the square, but small in size. Okay. Similarly, hexagonal pyramid. In the hexagonal pyramid also the base will be hexagon, and similar kind, one external plane will be cut this pyramid in the middle of that part or anywhere in that, and that will be that object will be, this will be parallel to the base one. So we will get a hexagonal pyramid, and that will be frustum of a hexagon. Okay. And similarly, the frustum for a cone will be there. Similar, when one plane will be cut the cone at any part of this cone, so we will get the frustum of a cone. So this is frustum of a pyramid, and this is the frustum of a cone. The next part is the label. How to labeling a prism or pyramid or cone or any kind of things. Okay. So we have discussed about different kind of pyramids and prisms, about how to mark it actually. So this is the base is there, ABC, and the center point or the axis line, top will be apex point O, and this base center point O. Similarly, if a square is there, square prism is there, then we need to see the bottom. This is the bottom part or base part, that means a square. So ABCD. Similarly, top will be there, that also need to mark 1, 2, 3, 4, or EFGH, something we can mark here. So both should be marked clearly, because when we will go for the projection, we need to project the bottom as well as the top. So there it is compulsory to mark the front view and top view with different names. Similarly, this is a triangular prism is there. Okay, a triangular prism, again base will be ABC point, suppose. This is the base part is there, and top is given 1, 2, 3, or some other names we can give, EFG, PQRs, and this is the midpoint of this triangle base, midpoint of this, and this is the axis line of this. That can be given O over 1, O over dash, something we can give it. Similarly, all these things like it is a square prism is there, and this is a cube actually, and this is the square prism is there. Now here also we can mark this square prism A, B, C, D the base, and top will be 1, 2, 3, 4, and this is the axis line of this. Similarly, all this pentagonal prism, hexagonal prism, cylinder, cone, and triangular pyramid, square pyramid, pentagonal pyramid, hexagonal pyramid. So everywhere how to mark it. See, this is the, suppose a cylinder is there. So base we are having a circle, and top also we are having a circle. Now if we are projecting this circle, or we are dividing the circle into number of parts, okay, number of types of part is there, 1, 2, 3, 4, how many parts are dividing. Each part need to be marked by a text A, B, C, D, E, F, G, H, I, J, K, or 1, 2, 3, 4, 5, 6, 7 to 12 points. So these are the labeling, how to give the text in the prism and pyramid part is there. Okay, and this is the orientation of the solid. So orientation means what are the types of solids are there, how it is divided actually. So the orientation solid is categorized into 6 types are there. When the axis is perpendicular to HP, axis is perpendicular to VP, axis is parallel to both HP and VP, axis is inclined to one plane, parallel to other plane, axis is inclined to one plane, parallel to other plane, and axis is inclined to both the plane, HP as well as VP. So this is the types of solid and methodology of solids, or you can say different types of solids are there, descriptions are there. So this is all about the theory part in the projection of solids. So in the next lecture, we'll discuss how to draw the projection of solid in the AutoCAD. So if you are having any kind of doubt, you can give a comment on the comment box. Thank you all.